Let us design a social media feed that serves millions. The naive version is tempting. One database holds all posts, and to build your feed, you query every account you follow and sort the results every single time you open the app. With a handful of users, it works, it feels clean, and it ships fast. But here is the trap. With millions of users and billions of posts, that query runs constantly. Every refresh fans out across thousands of rows. The database melts under the read load, and feeds take seconds to load. The naive design does not just get slow, it collapses. A feed at scale is not one big query, it is a system. So let us build it properly with everything from this series. Start with what the system must do. Users can post, follow others, and read a feed of recent posts from the people they follow. Now do the back of the envelope. Imagine 100 million daily users. Each one opens the app many times a day, but posts only occasionally. That gives us something like hundreds of millions of writes per day, but tens of billions of feed reads. The defining fact is the ratio. People read feeds far more often than they post. Reads dominate writes by a wide margin, often 100 to 1 or more. That single observation shapes everything, because it means we should happily spend extra work at right time if it makes the common read path cheap and fast. We also need media, like images and video, and we need it all to stay up under spikes. Split the system into two paths. The write path handles a new post, it goes through the gateway, gets stored durably in the post store, and then triggers follow-up work. The read path handles opening the app. It returns a ready feed as fast as possible, ideally from a cache, in a few milliseconds. Posting is the write path. Loading your timeline is the read path. The hard question lives right between them. When you post, how does that post actually reach the feeds of all your followers? Assembling a follower's feed is the expensive part of the whole system. The answer to that one question is the core design decision of a feed. And there are two classic strategies. The first strategy is fan out on write. When you post, the system immediately pushes that post into a pre-computed feed for every one of your followers, usually through a queue and background workers. Reads are then trivial. A follower's feed is already built and sitting in cache, so loading it is one fast lookup. You did expensive work once, on the rare write, to make billions of reads cheap. The second strategy is fan out on read. You store the post just once, and the feed is assembled on demand by pulling recent posts from everyone a user follows and merging them. Writes are cheap, but every read becomes an expensive scattergather. For a read-heavy feed, fan out on write usually wins, because it moves the cost onto the rarer event. Exactly the principle we set up earlier. But fan out on write has a famous failure. Imagine an account with 50 million followers posts a single photo. Now that one post must be written into 50 million separate feeds, all at once. That is a massive bursty write storm. The queue backs up, fan out lag spikes, and the whole pipeline can fall behind. The fix is a hybrid. For normal accounts, keep pushing posts to followers on write as before. But for the small number of celebrity accounts, do not fan out at all. Instead, store their posts once and pull them on read, merging the latest celebrity posts into the feed at the very last moment. Most users still get a fast, pre-computed feed, and the rare giant accounts no longer trigger write storms. You blend push and pull based on who is posting. Now assemble the full system, with every lesson from this series working together. At the edge, a CDN serves images and video close to the user, and rate limits at the gateway protect us from abuse and runaway clients. Behind that, stateless feed services sit behind a load balancer that spreads requests across the pool. Hot feeds and timelines live in a cache for instant reads, so the common path never touches the database. Posts and the social graph are kept in data stores that are sharded for scale, so no single machine holds everything, and replicated for safety, so a failed node does not lose data. Fan out runs through durable message queues with idempotent workers, so a retried job never double posts. And every layer is watched: feed load latency, fan out lag, cache hit rate, and error rates. Each piece here is a lesson from this series. now combine into one architecture. So here is the mental model for scaling almost anything. Separate the read path from the write path and do the expensive work on whichever one is rarer. Fan out asynchronously through queues instead of blocking the user. Cache the hot path so the common reads are instant. Shard for scale and replicate for safety. And always design for the extreme case, like the celebrity account, and for failure, because both will happen. A scalable system is never one clever trick. It is these patterns, chosen and combined deliberately for your workload. And that completes the distributed systems design sprint. You now have the full map, from one server to many, through load balancing, caching, replication, sharding, consistent hashing, consensus, message queues, data stores, global serving and rate limiting, all the way to a complete scalable system design. Take these patterns and go design something that scales. Thank you for watching.